Today, I will introduce a 40 feet container energy storage system to you. The container is divided into two parts. The left is the inverter system part, and the right is the battery energy storage part. The battery energy storage part is composed of 12 clusters of high-voltage batteries, total capacity 2.89 megawatt. And the battery per cluster is about 241 kilowatt-hours. Each cluster of batteries is composed of 15 packs in series, which are then connected to the high-voltage control box, and finally imported into the DC combiner cabinet. And you can see the inside of cabinet here. Now 6 clusters are displayed here. And there are also 6 clusters on the back. Connect each DC circuit breaker separately. And this is the emergency stop button for the high voltage bus cabinet. And then the above are the control and communication system of the entire DC battery stack section, including DC switching power supply, AC switching power supply, respectively to power bow. Here is the 24-volt power supply switch and the surge protection switch, and AC auxiliary power and sockets. Here are the CAN port communication and 485 communication part. And then you can look at the state of the entire battery stack through such a screen. It integrates the voltage and current SOCs information of each cluster of the entire battery stack. You can also see the data of the corresponding individual cells in each pack, as well as the temperature and voltage. Enter the inverter compartment below. The inverter compartment is divided into the inverter part of the main body, the auxiliary power, and the digital media box. As you can see, this is a 500 kilowatt PCS, and then it goes with these two PV split cabinets. And it comes with about 300 kilowatts of photovoltaic access capacity per cabinet. Can actually be increased to 375 kilowatts. The total is up to 750 kilowatts. Then you can see that on the right, the fire protection system of our entire energy storage chamber, including fire, gas tanks, and fire control centers. It will have a smoke alarm and release fire fumes if a fire is detected in the energy storage battery compartment and equipment compartment. And then here are 4 cooling fans. Ventilate and dissipate heat to the entire inverter equipment cabin. Here is the digital media box, including remote routing and EMS control system. This is the surveillance camera. Then here is the distribution and auxiliary power control box of the entire energy storage container, including total circuit breaker and AC surge protector. Circuit breakers for every air conditioner and fan. There are also circuit breakers that monitor digital media boxes, lights, and power of the fire control center. Then it comes to the back of it with the same structure, includes 6 battery clusters and a DC combiner cabinet. It's the same configuration as what you just saw. Then a 6-way DC circuit breaker, and the input below also has an emergency stop switch. The above is the circuit protection part. 12 cluster battery communication and DC switching power supply, DC surge protector. So how do you power it? First we need to open our battery compartment. Then turn on the BMS on and off switch buttons on the 12 cluster high voltage control box respectively. Wait for the high voltage control box to power on and the relay to close. You can see that there is a relay status here. You can see the main positive relay, and the main and negative relays have been closed. Reprints the two ports of P positive and P negative already have voltage outputs. At this time, you can turn on the manual switch for voltage output and power output. Then turn on the switch of each circuit breaker of the DC combiner cabinet accordingly. One breaker controls one battery cluster. Wait until all DC switches are turned on. Then go to the equipment compartment to start the inverter system. First, open the MPS 500. You can see that this part is the switch of the surge protector and the switch of the drive circuit. First, all switches of the drive circuit must be turned on, and then there's DC. That is, the output of the battery and photovoltaic are all integrated into the main switch of the DC switch. Then turn on the DC switch. The whole screen will light up. Then wait for inspection. If there is no alarm message in the upper right corner, it means the whole system is complete. Then you can turn on the grid, photovoltaics. Here is the circuit breaker on the load side, and the circuit breaker on the grid side. Requires rear access to the grid. Then wait for the entire PCS system screen without any alarm. Then turn on the grid. Open load. And the photovoltaic split cabinet here. Each photovoltaic needs to be connected separately with PV input port on the left. The photovoltaic output interface on the right, we have already wired up. No need to change it. Wait for the photovoltaic connection to be completed. Then turn on the circuit breaker and total output switch of each photovoltaic. The two split cabinets are of the same construction, so another split cabinet switch also needs to be turned on. When everything is ready, including photovoltaic grid cells, all of them have no fault display. At this time, you can click the switch button on the home page of the screen, including switches for photovoltaic conversion and switches for DC-AC inverter. This is the auxiliary power control. The auxiliary power box has been connected to the power grid side and the load side at the lower end of the converter. And this is a two-way switch. Down is the load switch. Up is the grid switch. See which one has electricity, and you can take which one. Then the switches here all need to be turned on. Now it can power individual air conditioner as well as fans, digital media boxes and lights.